Aromatics. Aromatics.
Well, Taylor, I'm excited.
I'm happy now too.
That last chunk of questions, you know, when I was just like, I can't think of anything else. You know, I just lost it. That really helpful.
It really saved me. I was carried up from the bed.
You know, it's a long test.
I mean, later I remember things, but at that point I had checked off everything on my list, but I had put every word on my list. So, okay,
This is
so
fun.
these are motor neurons, right? So where do we find them?
Ventral horn.
On the spinal cord. Finish the thought. Ventral motor spinal cord. What are these nuclei are?
Oculomotor neurons.
What?
Oh.
Glial
I
cells.
just said that's what these are.
Glial?
Wait, what? That's what I'm thinking. That's not neuroglial cells.
Glial cell.
Yeah, neuroglial cells. That's right. That's right. Okay. So where would we find this?
Ventral horn and spinal cord.
That's right. What would it be connecting to?
The sixth slide.
Corticospinal,
Track.
right?
Yeah.
And where are those fasciculi?
And then the anterior.
And
Anterior and.
why don't you look it up? No. I'm just gonna have to work. Look at that. Look at that chart. Look at that chart. You gotta make this. You were trying. You were giving me some other parallel words, and that was good.
Cerebral cortex on one side of brain.
Well, in the spinal cord.
Crosses.
Decussates in the medulla, the tracts decussate in the ventral medulla, called to cross.
The great portion.
No. In the medulla, the tracts cross, and that's called decussation
Oh,
off the tract. In the pyramids, and that's what they're also called the femoral tracts. So they decussate in the ventral medullary pyramids. And that's what they're called also femoral tracts. But now, where are the other corticospinal tracts?
This one says anterior cortex.
This one has lateral corticospinal.
Yes,
tract.
anterior and lateral. Funicular. Thank you. Yay. Anterior and lateral tracts. Okay?
Anterior and lateral.
So if you look at that picture, we're going to see those positions of those guys. So we're trying to put pictures together now, right? If you learn, this something you learn, make that sense. Thanks, please. Oh, Charlie's not here. Just
No.
do it, Charlie. Where's Charlie?
His practice started
I
early.
know, I'm just teasing. It's got to be one of these.
Sometimes the big like four. Let me see if it works. Sometimes it likes two, sometimes it doesn't. Wonderful.
Now, what's that? Same thing, right? And then remember, this is a little bit of, you know, error, basically. It's not focused as well, but is your sliding button focused?
Yes. Does it focus?
It may not. No.
No. Okay.
You want to be like that?
Do you want me to move
No,
to
it's
Charlie's
okay.
seat?
It's okay, I can walk, I need the exercise.
Yeah,
I found out 3 starts this morning before my family would fit around my belly that evening with the red line.
It happens to me too.
Oh, it's awful. I don't want to be in pain all day. So just say, next. Okay, so big carry-on. Now here we don't know which one of these, multipolar one, because we can see 1, 2, 3, 4, kind of 5 processes in just this one view. So we know it's multipolar. It is one of our alpha motor neurons. We know that. There's the nucleus with a distinct nucleolus, very common. There's lots of brain material in this, and this is called missile substance. And I think I've got that listed on your sheet that I handed out. And that is the endoplasmic reticulum. Okay, so that is NISSEL. But look on your sheet. I think I have
Where do you think it's at?
Well, it's just under the neurons on the probably histology.
Which one?
Nervous system. It's at the very top. So it's the rough ER.
Oh.
So that's kind of looking at this slide, what you can see. And the first part, we can't really tell which one's which. But in this one, I have a better guess. It's definitely not this one, and definitely not that one. But it could possibly be this one or that one. That's called the axon hillock, which is the first portion of the axon. And it most likely is this one, so you can look at what's inside, continues in that. And that's where we have to get that depolarization stimulus. We have to reach remember, an EPSP, an excitatory postsynaptic potential, at that part of the axon hillock to get the rest of it to depolarize. Okay? And so very active also in neuronal transport, for transporting neurotransmitters from even the cell body all the way down to the end of the axon. You know, that can be a huge distance. All right? So very, very active neurons when that's the part that has to be normal study.
Do you want me to go to the next slide?
Oh, yes, please. Let's go walking. So very same thing, right? It's just pulled away here, and you can see how it kind of gets shredded away, making that space. But this is a nucleus of, these are nuclei of neural glial cells. All the others are processes, and this is big, you see the nucleus, you see a distinct nucleolus, and then all the brainy stuff in there is the missile substance. You see some pretty good sized mitochondria, of course, high energy demand, high oxygen usage. These are definitively aerobic cells. You know, we don't want the brain and the heart to go without oxygen within that 3 to 4 minutes, so we're going to have the loss of tissue. And because they're so metabolically active. But that's the part that's keeping the rest of the neuron alive.
Next slide.
Yes, I don't learn very fast. And I love this guy. This is my favorite because he looks like a fish or a little shark, right? But he's like a whale shark because he's got a big long nose. Come on, laugh at me. Just laugh. Just laugh at me. But see, doesn't it look like his little eye, but then where he's got teeth?
That's so funny.
That's so funny. I just like him. He uses me. But he is a multipolar, very carry on, as you can tell. But I like him. So you can definitively see this very long process, right? Going all the way off the page here. So, same structures, your glial cells, all this brainy stuff. These are all the processes.
Next one.
Yes, please. No learning, no learning. So that must be a blank. You know, actually, it's a real blank. Let's see. I guess if you compare, I can take this over here. Let's see. I'll put it right here. There's not much light over here. Okay, keep going. Let's see.
Another blank.
Oh, then I've got a fish. I've got fish and a smiley face in the book.
It's supposed to be like this.
Okay. And then whole 54, the effort motors is missing. That must be in surveyed tissues. And then there's 43 should be blank, so click again. Okay, and now we're to 84. So now these are myelinated neurons, and so that's really cool. Okay? So what you can see is, remember we talked about the relative amount of myelin. That some of them have great age. Now, have y'all ever heard of vinyl records?
Yes.
Put on it.
Well, the Lincoln comeback.
Have you made fun of my funiculus before? But anyway, they make you think of vinyls. Okay. But you can see some of them have a huge amount of myelin, and some of them have a smaller amount of myelin, right? And what determines speed of conductance? The amount, that's right, the diameter of the neuron based upon what? Also the amount of myelin that's around it, that figures that myelin. So you can see some that have just a little bit and some that have a whole lot. So we've definitely studied those fatty proteins inside that make up the myelin sheath. What's it made by in the peripheral nervous system, since this is a nerve? Schwann cells. That's right, so these are Schwann cells. And then you'll see some little guys that actually have no myelin. So there's some myelinated and unmyelinated travel in the nerve together. So if we look at this, we can see that there's some bundles. So what's a bundle called in a nerve? What's the word for bundle? Fascicles. So these are fascicles or bundles. So inside the nerve, you have the same three membranes. So what would be this connective tissue membrane that surrounds this bundle? The bundle. Perineurium. What would be surrounding the individual cell in here? Endoneurium. What would be surrounding the whole nerve? Epineurium. See, it follows the same pathway of saying this is the pathway of organization. So in a nerve, you have fibers going back to the central nervous system, and you have fibers leaving the central nervous system. And they're all joined together into one mass. And so that's why people are like, wait a minute, radial nerves are like this here, you're sending pieces out. And it depends upon the portion that's going there, right? You have to understand that. The nerve is the massive cable bundle, but then pieces of that can go different directions.
So you want to go to the next one?
Yes, please change.
Okay, now it's on. There we go.
Okay. So this is still the same or a similar nerve, but now what we have is a long section. And if you look at this guy, I'll focus just a little bit. We're really just trying for what's outside the cell, not what's inside the cell. So we're looking at mostly the endoneurium. But if you look at the endoneurium here, so look at this, let's just look at this one for me. So here's one guy. So this is the myelin sheath. Inside is either the axon or the dendrite. See, this is the axon or the dendrite, right here at the center. So this is the myelin, and then this is the connective tissue around that. And we have invaginations in the myelin, which means different cells. Remember, so 1 cell, 2 cell, 3 cell, 4 cell, that kind of thing, making up the sheath. These are the nodes of Rodvier. That would be considered the naked part of the neuron that we can't tell. And you can tell a little bit. See how far you can actually see it's invaginating? It's actually invaginating all the way to the edge of the process. And so at that point there wouldn't be. You can tell a little bit more right here. See how it goes all the way down to the thing at the center. So those are the nodes of Rodvier, and here you can see that invaginating all the way to either this axon or dendrite. So what type of neurotransmission does that give us? Saltatory conductance. And the word saltaire means to leap. So leaping conductance. And I always say for me to get to South Knoxville, I only have to get to Mumford Pharmacy this afternoon.
So the thick red is the endovascular and the
Now, endoneurium.
endoneurium, and the more faded red in the middle is the axon or dendrite.
Mm-hmm.
Okay.
Ah!
Oh,
What am I writing?
saltatory conduction.
Yeah.
I'm sure you pronounce it different.
Saltatory. That's right. And so we essentially leap from the naked neuron to the next naked neuron, and that's the nodes of Rodvier. So, long section. So you know that we have to be looking at a nerve because we have so many of these guys lying side by side. And then that's probably of a similar type because it looks like the thickness of the myelin sheath is similar.
Next one.
So same kind of thing, but now it's stained for the myelin. And as a result, you can clearly see these cute little guys, right? What's this? Node of Rodvier. Node of Rodvier. Very nice. Okay? So we've got more of the myelin, so what might be the white stuff?
The endoneurium.
Very good. Excellent. next.
Alright, 1 second. Okay, let me do it on here. This thing is not working.
Now, this guy's considerably bigger than that guy, right? So you see the little channel down the center?
Nope.
Now what's
Sorry.
this?
And then I have to come back.
Axons.
Sit down.
What kind of view and visual is this? A transmission electron micrograph,
Oh.
right? So that's a TEM, but remember you only get half credit for TEM. You gotta write down transmission electron micrograph. And so now we can see subcellular structures, which is really cool.
Go to the next one.
No, I'm waiting for you to write that down. Nobody's looked up that video. So if you look at these guys, here's a, right? Here's a nucleus of the cell. You may not see that. But what's missing around the outside of these guys? Yeah, myelin. So that dude's myelinated, and these guys aren't. And look, it shows the cytoplasm of the Schwann cell. So this is it's wrapping, but then you see where you actually get to a place that there's a bit of cytoplasm, you can even find the nucleus. But that's its multiple wrappings around that axon. And what do we see some big things on inside that axon? Mitochondria. And of course we do something called axonal transport, and that's how you get those neurotransmitters that are made in the cell body all the way to down to the end. But we know that the ends are also active in production. Now what might we have up here in the corner? Muscle. It shouldn't be a muscle. It should be one dudes that aren't myelinated. There's a long section of those guys. Isn't that cool? So here we say Schwann cell cytoplasm, but there's no wrapping. They haven't generated a myelin sheath. So very little increase in transport. Next, please. Oh, let me see if I, hold on just a second, let me read and see if I finished anything. I don't know which one this is. You may know.
47.
47?
Yes.
Okay, I don't think it's, yeah. 47.
The next one?
Uh-huh. Is the button not working?
No, sometimes it does, sometimes it doesn't. I don't know what I'll do.
Oh. That's weird.
Well, this is a scanning.
Oh, very good. Yay, Taylor. See why you needed to stay? So that's a scanning electron micrograph. So now you can see the surface. And it looks kind of like this little thing. So here are the blood vessels, right? And both of those are probably what? Both of those look like arteries because they're lovely, nice, and open. We got some little smashed veins up here. So then what's going to be around each of these individuals?
Which individual? Endothelium.
Yeah, endothelium, right? And then what's around this whole group? What's the group called? A fascicle. So then that would be peri.
Perineuria.
And then if we can see around the entire thing, well, they're saying it's up here at the top. So that's the epineuria, just like you know. So look at all these little bundles, and you can imagine that they're going to a similar tissue, right? This is one nerve, but these may be the ones going to one place, while these are the guys going to another place. But you can see inside the little axon, right? Isn't that cool? Next, please. Or did that. Now, what's this that you've seen so many times? Well, now remember, you're seeing more than that. Yes, you are seeing an neuromuscular junction, but you're also seeing part of the motor unit, right? It's part of the motor unit that includes a neuromuscular junction. Everybody did their own test, so I decided to give you credit for it. And I think everybody put neuromuscular junction. And this part is a neuromuscular junction for sure. That's part of the motor unit too. So, if you look at these guys in long parts, you can see 1, 2, 3, 4 muscle cells in that view. They are striated, wide dark bands. We can look at those. We can look at some of the cells, the nuclei of the fibroblasts that are in what connective tissue membrane? endomysium. Now don't confuse those words, like Taylor bless your heart. You did a whole bit of the stuff on the hand and call it Callissus the whole time.
Listen, the hand is a different breed.
The hand of the thumb, yeah, either one, you know.
We'll figure it out.
Okay, and so what do we have here? What's this guy and that guy? The swirly guy, you said.
The axon.
Axon terminals, and then what's this thicker guy here?
The axon.
Probably axon itself, and then up here you see some more squigglies that may or may not belong to the same one. But then we can see these bigger cells, and there are these bigger nuclei. Those are the cells where we actually form the muscle tissue, right? So that's the multinucleated skeletal muscle cell. All right, next one. Oh, good. Well, let's focus in on that. So this is true. You can see a whole lot there of the motor unit, including the neuromuscular junction, right? But that is where the muscle's coming in. And what's cute is you can see these guys sitting there, right? So remember we got the blown out part of the neuron, but we've also got the part underneath on the muscle that interacts, correct? And that forms then that junction. So here we see it from the top, and what might be all these dark things here? Most of those are mitochondria because they're so large, they're probably not the presynaptic vesicles, but they're probably surrounding. So this tells you it's very dynamic. So there's 1, 2, 3, 4, 5, 6, and so we call those a motor end plate with the, at the neuromuscular junction. So then in comes one or more axons, and then these are axon terminals, and then those are the myofibers that are innervated. But they're really cute, right?
They're adorable.
They look like little lepers or something, don't they?
They look like fish eggs.
Fish eggs?
Yeah.
Huh, okay. Maybe, yes, we do.
Or like a bunch of tadpoles, you know how they look.
My little grandkids were saying, that fish has legs. It's like, no, that's not a fish. Okay, so, there's a blank, let's see, is that blank 55?
You mean 51?
That blank is 51, you're right. Thank you for keeping that.
And then so go to the next one, see if it's blank.
Hold on just a second. 51, yeah, it's not supposed to be blank. So that's probably in
Survey
or somebody's pencil. So this is missing. 51's missing. I'm probably coming on. Okay, go to the next one.
Oh, come on now. There.
Oh, okay. So what do we have there?
Motor unit.
One with a nerve.
Yeah, same kind of thing. So that's an axon terminal to the left. Now, truly, you could call this one a neuromuscular junction because it's just that, right? We don't see all the other pieces, parts. But you can easily see that, the end, which is the return terminal, interacting the muscle, forming that junction. That's great.
Okay, I have a question. Sorry, let me raise my hand.
No, I stopped and I'm looking at you. Yes, Caroline.
What's the difference between a motor end plate and a Bruton terminal?
The return terminal is the part of the neuron, and only the part of the neuron.
Okay.
The neuromuscular junction or motor end plate is the combination of the two.
Okay. Thank you.
So next.
Within the motor end plate is the functional neuromuscular junction. Does that make sense? Okay. Next one.
53.
53, it is missing. Okay, next please.
Bada bing, bada boom.
Now, cool. Now, mammalian people. Let's think back to mammalian. Now, my physician's assistant's going to take zoology. Because he can take up the friend, and that's what his mother and friends suggest that he takes to be a physician assistant.
What?
Well, girls take it.
Take zoology instead of
I
math.
took zoology, but I'm gonna be the best.
Takes a while,
That
it takes
makes
a million to
little
be a
more
TA.
sense. But you're also
What?
saying
That's
these
stupid.
roads
Why do you think
to
I'm taking
learn
the
the mammal,
Yeah, it's,
right? Now,
if you're doing like anything medical.
what we're looking at here is a spindle.
So, you know,
Now, y'all remember what a muscle spindle was?
yeah.
fiber?
Inside, particularly your anti-gravity muscles, those are the muscles that hold you up and give you posture. Right. So your anti-gravity muscles contain lots of these. And since your body tends to flex with gravity, what might a lot of your anti-gravity muscles be? Extensors, like your erector spinae, your back leg muscles, all right? Prevent that from happening. So when we looked at all the parts of the spine and we looked at how we align our segments, remember when we did that? We did that, the alignment of the segments of the body. And then those are the muscles that keep us upright. So they have lots of spindles. A spindle is from weaving, is what you would wind, so a little spool that you wind the yarn around. So it's skinny on the two ends and chubby in the middle, kind of like my body. But anyway, so that's a spindle. So it's a microscopic structure, but inside the spindle, you have muscle fibers, right? But these are non-muscle force generating fibers. But they're inside the spindle, and so they're called intrafusal fibers. Right. And then outside, you have the regular muscle cells, and then those are called what? Extrafusal fibers. So if we look at this, here's an extrafusal fiber, here's an extrafusal fiber. So these are regular skeletal muscle fibers that we see on the outside here. So let me get another color. So then out here, just surrounding this guy, you have all the regular muscle fibers. But see what we've done in this is a complete cross section, right? We've gone across it. And these are our force-generating fibers. So in this view, extrafusal, right? These are the force-generating fibers out here, and for you people who've got it pulled up, it's probably these guys over here too, right? But then this is a cross-section of the spindle itself. And so, you know, we have our connective tissue membranes. You can see some fiberglass-like cells that they surrounding that. But inside there's 1, 2, 3, 4, 5, 6, 7, 8, could be one in there, 8 or 9 intrafusal fibers. Do y'all see that? Okay. So now we find lots of spindles in our anti-gravity muscles. So there's an increased number of spindles there. Now why? What does the muscle spindle give us? It measures stretch. These are our stretch receptors. And you'll use that clinically. So if we want to check on how well the pathway through your spinal cord and back out works, you will test for a stretch response. All right? So let's say, for example, that you tap.
Just like the nerves we did in,
If this is exactly
Yeah.
this, we talked about it all then too. This should be familiar. So when you tap, so clinically, the physician uses this to check the integrity of the pathway into and out of the spinal cord, right? So it's doing peripheral and central combined. Is this pathway intact, or have you injured yourself so it's not intact? So for example, you can do this with any tendon in the body, but the one that we use is superficial. Remember, you sat on the edge of the table and we tack the patellar tendon. So what happens, and here's the quadriceps muscles coming down. There's the patellar tendon. You know, there's the tibial tuberosity, correct? And so that's the quads. So what happens when you tack that tendon, if you look from the top, the tendon is like that long, and then you whack it with a hammer in the middle, and it does what? It stretches. It stretches, because when you tapped it, you made it longer. You stretched it by whacking it with a hammer, right?
Yes, ma'am.
So this is called a stretch reflex, because what happens is, around each of these little intrafusal fibers are little receptors. And they're wrapped around the fibers, so they're called annulospiral endings. So, what we might see, some of these guys even could be of that receptor, but these guys wrap themselves around, so you can see it's the whole thing is wrapped, the whole spindle is wrapped, but inside the little receptors down there. So what happens when you tap that tendon, if you bring all these fibers down together here, even this spindle comes into this. So this is this tendon over here, right? That's what we're whacking. So when we whack that tendon, it also stretches the spindles in, correct? And when it does, when it stretches that, it takes that little coil spring and does what to it? Come on, right? It stretches out that little spring. And when you mechanically stretch out that little spring, it fires. So it's going to fire and it's going to go back into where? Well, it's going to go back into, yeah, there we go.
And then the dorsal cord. And the motor neuron.
And then we're going to connect, exactly.
The quadriceps contract and the extend.
Yes, excellent.
That's her mammalian notes.
I pulled it up for ma'am.
Good.
This exercise
Excellent, see? And I told you the time we'd get to see a picture, but y'all didn't believe it. That's too long ago, right? Very good. All right, so now when we fire this guy, well, here's our spinal cord, right? He goes in the spinal cord and he's going to link up with a what? Well, if it's the quadriceps, this little neuron is going to be part of what nerve? Femoral. How about that?
Yes, ma'am.
Right? And he's going to come over and he's going to activate the extrafusal fibers to contract. And what happens when the quadriceps contract? Boing! Right? You get extension of the knee. Now that tells you that this entire pathway, all the way through, has been activated, right? We've gone in, we've activated, we've come back out. But now we've got a problem. When these guys shrink up, guess what's left hanging out the bottom?
And the intrafusal.
The intrafusal fibers. So, we also have a little, so this guy, when we go in over there by our purple also connects to a pink. So when the purple comes in, there's a little pink guy, right? Now what's he called? If that's an alpha motor neuron, what's he? A gamma motor neuron. So the little gamma motor neuron is going to come out and go to what? The intrafusal fibers. That gamma motor neuron. Whereas the first one was an alpha motor neuron. And what's, you know what we're going and what's the beauty of that? Now the spindle can continue to measure the length of the muscles. Because what's the problem if your muscles get stretched too much?
When I said an actin,
the actin and myosin will no longer overlap and you can't get a contraction. So it's called a stretch reflex because its job is to prevent the muscles from getting so stretched that they can no longer contract, and particularly our anti-gravity muscles, because what happens if they don't work? We fall down, we go boom, and we get hurt.
We go boom.
Right? Okay? So this is a muscle spindle. So that's beautiful, right? Muscle spindle. Cool? Yeah. Alexis, they've had this before. This is your first turn. You got it?
Oh yeah, that makes
Okay.
sense.
Okay, good. That sounds like nothing else does, but that makes sense.
Well, no, that actually did make more sense than a lot of everything else.
Okay,
That made
good.
really good sense.
Okay, and then, look, I've got, look at all the information I've been doing. Muscle spindle, extra intrafusal. Oh, well, that didn't make any sense anyway. Extra.
Is this one supposed to be blank number
Yeah, that was
56?
supposed to be blank.
Okay, to go to 57?
Sure. Let me add some words here, because extra intrafusal doesn't make sense. Extrafusal and intrafusal. Okay, next.
This is 57. It's
And
also
50
missing or blank.
55 should be blank, 56 is blank, 57 is blank.
Okay.
And that's in, those are all in, survey of tissues, okay?
Okay. There we
All right, so that should, is that 58 then you think?
go. 54, 55, 56, 57. This should be 58. Yes.
Okay.
Triple checking. I'm pretty sure it's 58.
Well, guess I'll stay.
Looks like it's 52.
55, 56, 57. Yes.
Yeah. Can we stay after this?
Yes, that's the 57.
Okay, so this is 57.
I'd rather take a picture and get it ready today. rather than-
Okay, so 57 is not missing. All right, sympathetic ganglion. Now, I really got to do a bunch of lecture stuff on this too, but these are what?
Pericardium.
They're pericardions, but this is in a ganglion. So if it's a ganglion, you know it is.
Peripheral.
That's right. A ganglion is a collection of neuronal sub-bodies outside the central nervous system. So, new picture.
No more pictures.
Jesus, tired page.
No more what? Okay.
Alrighty then.
It's not crazy. Histology does that.
Makes you crazy. Yeah, I'm gonna do the lecture.
Okay, so we're taking a break from histology.
We're taking a break, just a second, for me to give you the background information to understand this.
Gotcha.
Well, that's There's only 15 minutes to do all this.
Speed rounds, go.
Okay, speak up.
Actually, less than 10 minutes.
Okay, so we have our central nervous system, right? Woo! That's a cold. Come on. Okay. So we have, I know, I forget about it till I'm in a dress and then I stay right over it. Okay, so now we have our somatic nervous system. And we have our autonomic nervous system. Correct? And the word soma means what? It means body. So, first of all, let's look at control. So if we compare these two and we do control, what color do you want somatic to be? Orange.
One you can, one you can't.
Okay, so somatic control you can, so it is volitional. Or voluntary. Right? You control it. So this one is what? Involuntary. And what color is it?
Blue.
Blue.
Carson knew.
Oh, orange and blue. I didn't get it till just then.
Now you forgot where she works. She's a coward.
She's gonna retirement
I
now.
sure am spending a lot of time, but I won't do anything. Okay, so the control, volitional and involuntary. Now, I want you to realize there's some Tibetan monks that, and we can teach, can do this, and we can teach people with biofeedback to control their heart rate and blood pressure and all kinds of things that we consider autonomic. So I want you to realize that there is a little gray line in there, correct?
For the monks.
Well, for the monks and certain
Just for the monks.
Now, other people can learn to do it, okay? Because people can be taught to lower their blood pressure. They can control an autonomic. Yes, you look at a little light, and when the blood pressure's high, you turn it on, and so you focus on it to try to get the little light off, and you train to do that. She's doing it right now. Yes. So I'm saying, this is in general. This big old brain can do all kinds of stuff, and I truly believe we haven't figured out yet. And eventually we will. Okay? But right now, this is what we're doing. Okay, so the control. Now, so what are the effectors? Oh my gosh, that is so cool. Effectors.
This is a gray area. It's gray matter.
That's great stuff. So what are the effectors over here?
Skeletal muscle.
Skeletal muscle. What are the effectors over here?
It's not cardiac, right?
Cardiac muscle. Cardiac and smooth. S-M-O-O-T. And glands. Yeah.
So it's outward and also
So it's first and forest. Okay, now, let's see. Where do I use here? Stimulus. In skeletal, or for skeletal muscle, the stimulus is always what? It is always excitatory. If you get a stimulus, it's going to stimulate the muscle. If you don't get a stimulus, nothing's going to happen, right? So if you get a stimulus, it's going to be excitatory. But over here, the stimulus can either be excitatory or inhibitory. Because what we need to understand about this system is that it is what? Important.
the balance.
I miss
Positive feedback is the mechanism for life and death.
Ooh. Oh, I remember that.
Not in death, for death.
Life and death.
Like and death. Okay, so innervation. Since this is excitatory, there's only one. There is one neuron, a single neuron. In the pathway, right? Now there are many neurons, but only one per our motor unit, right? Right, that's what I'm saying here. But over here, there's what?
Multiple.
There's actually two neurons.
But not three.
Huh?
three, just two.
That's
Oh,
two.
but one's to excite and one's to inhibit.
Ah! Actually, no.
Aw, man. Why are you like bashing me today?
There is a presynaptic neuron.
Yeah, that's what I'm saying.
Oh, wait. Wrong word.
Wasting time.
Preganglionic.
Sounds like a tomato.
Well, that's because sometimes I know what I'm going to get to. We just been talking about presynaptic neurons that are enormous conjunction. Preganglionic, and what was the other thing?
Postganglionic.
It must mean that we have what in this system?
Ganglion.
Ganglion, right? So one goes to the ganglion,
No one
and
goes
one's
to
in
the
the and then the process is leak. Okay? So there's two neurons, one preganglionic and postganglionic. But there's also a dual innervation. Single innervation. Now, Caroline.
One's to inhibit and one's to
Yeah, there we go. Yay! Now we got that. You were headed there. We just got it a little early, right? So it's dually innervated because there are two branches to this system, right? There is a sympathetic and a parasympathetic. And you know the old adage that goes with it.
Firefly.
Fight or flight, rest and repose, right? Okay.
I always said breast and digest.
Yeah.
So it's too expensive.
That's fine, too. But it was originally repose, right? Okay, repose. That's right.
It doesn't rhyme.
It doesn't go as well with digest. Okay, so now we've got two pictures here, but we have just a single system here. It is a mono innervator.
We're just changing flavors.
Huh?
Still feel like we're just adding these words that all mean the same. There's one neuron. A single innervation. Mono innervation.
It's mono.
You want to make sure you get it.
Right? How redundant can we be?
There's just one.
Okay, now,
It's so innovation.
what about neurotransmitters?
One using it. Yes, acetylcholine and others.
So, what are we using the one that's going to skeletal muscle? Acetylcholine.
Isn't that also used in the brain?
Oh, in the brain it gets crazy. We're doing peripheral. We're doing peripheral nervous system. Because if we get in the brain, it just goes all there.
Because you said neurotransmitters, I'm like, yeah, but like, what do you mean?
Exactly. All those single amino acids, so when people wonder why aspartame is a problem, guess what? What can amino acids do to you? In the brain, they're neurotransmitters. Yeah, that could be a lot, so let's talk about that.
Because I refuse to stop.
Did I not give you that article?
No, I didn't get it. I
In
didn't
the
get
mail,
it.
you maybe get that article
I
on
want to
taste.
know, we don't have more binders.
What was it in there?
I don't remember. You
Oh,
gave it to Director Greaves apparently, because Cody knows all about it.
yeah, that's because he had it with
Is this
me.
a sweet now?
He had it.
Or
with
artificial
me.
sweet?
Yeah,
Oh, I think you know that.
he knows all about this stuff.
Yeah.
Kind of sort of.
Now, that's sort of.
Alright, now, what are the neurotransmitters over here? Well, we have acetylcholine. Ouch! And we have How many times can I hit the corners of the
We have
table?
table.
And we have echinophrenoridina. Oh. So, remember here we have a ganglion. So in the sympathetic with our neurotransmitters. So pre-ganglionic, post-ganglionic. Let me put that in the middle.
Really throwing me off. You know, it's pretty organized now, it's not, right?
What's happening?
Because now I'm making divisions under these guys.
I love the vision.
I like subtraction too.
Like,
My 6-year-old granddaughter, she's like, grandmother, or grandma. That's grandmother. That's called subtraction. I said, you take this away. And she said, taking away the word is subtraction. She's like,
Brandon, I'm good for knowledge.
now you know.
229.
Speedrun, go.
It's 2:30, you gotta go.
Get out of here.
There, we'll talk to you guys anymore.
but anyways, I'm a good shot.
So now, we're going to put up the next time is how they're organized.
Are we done? I'm gonna stop the video.